All right. So these will be the product to sum. And then I'll do sum to product. So number one is sine alpha, sine beta, which is equal to 1/2 bracket cosine alpha minus beta minus cosine alpha plus beta. Number two, cosine alpha times cosine beta is equal to 1/2 times cosine alpha minus beta plus cosine alpha plus beta. Number three, sine alpha times cosine beta is equal to 1/2 sine alpha plus beta plus sine of alpha minus beta. I feel like there should be one more, but let me double check. I think there might be just three. I'm just paranoid. Okay, so we got cosine alpha cosine beta, sine alpha sine beta, so there should be one more cosine type. Cosine alpha cosine beta. We need cosine alpha sine beta. Yeah. Okay, that'll be 1/2 sine of alpha plus beta minus sine of alpha minus beta. Okay, so yeah. Okay, we're good. Sorry about that. The next one is going to be the next set. It's going to be sum to product. So this will be sine alpha plus sine beta equal to 2 sine of alpha plus beta over 2 cosine of alpha minus beta over 2. Number 6, sine alpha minus sine beta is equal to 2 sine of alpha minus beta over 2 times cosine of alpha plus beta over 2. All right, almost done. Cosine alpha minus cosine beta is equal to negative 2 sine alpha plus beta over 2 sine of alpha minus beta over 2. So that'll be cosine alpha plus cosine beta. That'll be 2 cosine alpha plus beta over 2 times cosine of alpha minus beta over 2. All right, finally. All right, so we're gonna need these guys for this section. I think that's all the formulas we need for today. All right.
Sir,
Yes.
for number 7, is that a negative 2?
Number 7, that's where? Sorry.
Is that a negative 2?
Yes.
Is that the only one with a negative?
Yes.
So it's the only one with a negative. All right.
Yeah. Just double check to be safe. It's the only one. So the homework is going to start out with just filling in the blanks of how the formulas go and what they're equal to. And then eventually you'll need to solve equations. Let's see here. Yeah. So let's get to those first. Have I given you the double angle formulas? I feel like I did a long time ago, but I want to double check. Does that sound familiar at all?
I don't remember it. I don't remember it being called double angle, at least.
Okay. Well, I'll write them down just in case then. So we may need them. For reference, I'm sure we did talk about it, but just for reference, sine of 2 theta was equal to 2 sine cosine. And then we had cosine of 2 theta equal to 3 different things. Where's that formula? Here we go. It's going to be cosine squared minus sine squared, or will be equal to 2 cosine squared minus 1, or it will be equal to 1 minus 2 sine squared theta. And then we had a double tangent as well, which was 2 tan theta over 1 minus tangent squared. I think you might have been in the proof section with the identities. Right, I could be wrong. But here they are. We're gonna need them. Okay, let's do. Well, we might not need them, but we'll see. You guys cool on this page? There's no rush. I just don't have any more space. Okay, turn the page. I thought I erased this. Dang it. So first equation, this is example 1. Problem 6 in your homework. It says find all solutions on the interval (0 to 2 pi). So basically just one period on the circle. So here is the equation. So the only reason I was thinking double because I saw this, that maybe we'll need it, maybe not. So let's look at our formulas. We have sums, right? This looks like we can apply rule 5. Five was what was this one? Sine of alpha plus sine of beta is equal to 2 sine alpha plus beta over 2 times cosine of alpha minus beta over 2. So make this your alpha and your beta. That's all you got to do. So sine of 2x minus sine of x is equal to 2 sine of 2x plus x. That's going to be over 2 cosine of 2x minus x over 2. Okay. So make that a little prettier. Let's see if this is helpful. So now we have the sine of x over 2, no, 3x, times cosine of x over 2 equal to 0. The 2 doesn't do anything. You can divide both sides by 2, which will basically cancel it. Now, are you guys with me up until this point? I applied the formula on the left-hand side. I got this part. So now this is equal to 0 instead of this. That's all we've done. Is that cool? All right. So when you have a product equal to 0, you're able to set this to 0. So when is cosine equal to 0? Do you remember? The regular cosine. Let's pull up our circle.
Pi over 2.
Yeah, pi over 2 for sure. And
And 3 pi over 2.
yeah, 3 pi over 2. So we know cosine is equal to 0 at those locations. So what you can do, try to make this as simple as possible. So when is this equal to pi over 2? When is this equal to 3 pi over 2? So basically, because we know that if the inside is 3 pi over 2, it will become 0, right? If the inside is pi over 2, it will be 0. So set that argument equal to the thing we're talking about. So solve for x, multiply both sides by 2, you'll get x equal to pi, x equal to 3 pi. Although this one's too big, right? Are you cool with how I solve for these? I skipped a minor step there. Is that okay?
Why is that one too big?
Oh, they told us to only look between 0 to 2 pi. This is 3 pi. So it is not a solution within the interval. You can't use it. Even though it is a solution for this equation, it is not within the interval. So we only got one answer out of that.
Oh. Thank you, dear.
Okay, so no, let's solve for this guy. When is this one equal to 0? Look at our circle.
0 and pi.
Yeah, 0 and pi. So set this equal to 0. Set this equal to pi. This one is clearly just 0. There's nothing to do there. That's the only way this will become 0 is when x is 0. When is this equal to pi? Well, I'll have to multiply both sides by 2 and then divide by 3. Solve for x and you will get 2 pi thirds. So one solution. 2 pi thirds, another one. All right, 1 second. Half angle formulas are the last for this section. For real this time. So sine x over 2 is equal to plus or minus the square root of 1 minus cosine x over 2. Cosine of x over 2 is equal to the plus or minus the square root of 1 plus cosine x over 2. And then the tangent has two forms. that will be 1 minus cosine x over sine x. Or you could use sine x over 1 plus cosine x. And a quick note here. The signs, see how they're plus or minus? The signs of sine x over 2 and cosine x over 2 depend on the quadrant in which x over 2 lies. So if it turns out your angle x over 2 is in quadrant 1, then sine and cosine are both positive. If it turns out it's in quadrant 2, then sine is positive, but cosine is negative. So all those ideas come into play when you're using these. Okay. Okay. Now let's go back to the homework. Problem 6. Solve the equation on 0 to 2 pi. So it's the same thing. It's just that this time that I know that we're allowed to use double, we will do so. So what is sine 2x equal to?
Two sine theta cosine theta.
Yeah. So this will be 2 sine x cosine x, right? Now, when you're solving an equation set to 0, you want to try to factor or create two factors. So they both have a sine x in common. So if I factor it, I'm going to get, I'm going to leave the 2 right there. So that'd be 2 cosine x minus 1. So this method will be a lot easier. So we don't have any weird angles like we had before with the x over 2 or whatever. Okay. So we said when you have a product, you will set each one equal to 0. Solve for cosine, then you will get cosine equal to 1/2. So now we ask the question, where is sine 0, right? I think you guys said 0 and pi, right? Last time. Where is cosine 1/2?
Pi over 2 and 3 pi over 2.
No, 1/2. Excuse me.
Pi over 3. And 5 pi over 3.
Yeah, that's it. So the solutions will be this set of 0, pi, pi over 3, and 5 pi over 3. So this is better, I think. And that's what they got here. So number 6, you apply your double angle on this guy, factor, and you get your 4 angles. Are there any questions on these steps here?
No, but that was so much easier.
Right? I think so too. The other way was weird. Need to write some extra notes here. Okay. So that's the first one. Any question on example 1? Seven's the same thing. They just have a cosine. So let's move on to something else. Let's check out number 9. That one's kind of weird. Use a double angle formula to rewrite the expression. So they give you 3 sine x cosine x. And they're asking you to use the double angle. But you see how there is the formula says it has to be a 2 in front, right? So how do we fix that? No, we want to use this. Sine 2x equals 2 sine x cosine x. So I need to have a 2 sine cosine, not a 3. So you kind of have to force the problem. So I'm going to ignore the 3. You agree that 2 over 2 is the same as multiplying by a 1, right? And you agree that I can move that 2 over here. I'll leave this 2 with this guy. So now this, we can apply the sine 2x. So then we get 3/2 sine of 2 theta, or 2x. And that's it. You just force the transformation, I guess, the identity. So they weren't asking to solve for anything. They just wanted you to rewrite the problem using a double angle. Are there any questions on number 2? Okay, let's see. Let's do 11. That looks kind of hard. You guys cool on this page? There is no rush. Example 3. Find sine of 2x, cosine 2x, and tangent 2x, given that sine x is equal to -3/5, and the x is between negative, or actually positive 3 pi over 2 and 2 pi. So this is the hint of what the quadrant we're dealing with, which quadrant we're in.
Your focus is really weird.
Oops. Sorry, it was moving too much. Okay, so in order to find sine 2x, we need sine and cosine, right? And you see that this is quadrant, but which quadrant is this? Can you tell?
Quadrant 4.
Quadrant, yeah, looks like quadrant 4. So that means that both sine and cosine are negative. So when you try to solve for your Pythagorean here, if I put x here, opposite over adjacent, sorry, over hypotenuse, be there. So Pythagorean theorem to solve the missing side. So A will be c squared minus b squared. A is equal to plus or minus the square root of c squared minus b squared. So since we are in quadrant, you said 4, right? Then we will choose, sorry, the only sign is negative, my bad. The adjacent side will be positive. So we will choose the plus. So 25 is 5 squared minus 9. So that will be 16, which is 4. Okay. So now I know that sine is -3/5, which means cosine has to be 4/5, right? Now I can begin answering the question. Part A, sine of 2x. So we know that that's equal to 2 sine cosine. So plug in the numbers, that'll be 2 times -3/5 times 4/5. So just plug in the numbers, plug in the sine and the cosine. So that'll be -3 times 4 is a -12 times 2, that'll be a -24 over 25. Any questions on part A? So we just use the formula and then plugged in sine cosine. You may need to solve for one or the other. Okay. All right. So cosine 2x, what do our formulas say? What is that equal to?
Either 2 cosine squared x minus sine squared x, or 2 cosine squared theta minus 1,
Yeah,
or 1 minus 2 sine squared theta.
what was the first one?
cosine squared theta minus sine squared theta.
Yeah, let's use that one. No real reason. I mean, they're all fine. If you only had sine, you could use the one that had sine in it, but who cares? We found both now. So plug in cosine. Plug in sine. So that'll be 16/25 minus 9/25. 16 minus 9, what is that? 7. So there's cosine. Any questions on part B? Okay, so now we do tangent, the last one. Tangent of 2x is equal to, what was the formula for tangent? I already forgot.
Two tan theta over 1 over tan squared theta. I really need to work on my handwriting.
2, I think it was like a, is that what it was? Or was there many different ones?
No, it was the only one you get. 2 tan theta over 1 over tan squared theta.
Let's use that one. So you said 2 tangent theta over, what was it again?
1 over tan squared theta.
Okay, so 1 minus?
Yes.
Already, so there it is. We have sine and cosine. What is tangent? We need it now, right? Yeah, -3/4. Okay, so just plug in -3/4 in these locations and we're done. So that'll be 2 times -3/4 over 1 minus -3/4 squared. So that will be some funky fraction. -3 over 2 over 1 minus 9/16. It's not pretty at all, is it? One minus 9/16 will be 7/16, which will be a product, right? Which will be still negative 24 over 7. There it is. Sorry, that was just a weird fraction, but you see the idea, right? What we're doing is plugging in tangent here and here. Any questions on part C? What else they did here on 11? They give you some information, they give you a quadrant, and you need to find all the other stuff and apply double angle formulas to each one of these. And that's what we did. So we found these numbers. Okay, the last few are just power reducing stuff. So let's do one of those. Let's see, what's a good one here? I don't know, this one looks weird. Let's do that one. 13. You guys cool on example 3? Okay. Example 4. This will be problem 13 from your homework. Use power reducing formulas to rewrite the problem. Okay, so they give us cosine to the 4th of 2x. So the power reducing formula for cosine squared x is equal to 1 plus cosine 2x over 2. So we're going to apply that twice. What do I have here? The expression. Okay. So basically just rewrite the question as cosine, to write that better. Cosine squared 2x squared again. You agree that's the same as to the 4th, right? Squared squared. So I'm going to apply the formula inside here. So that will give me, but it's already double. Notice how it goes from x to 2x. So it's going to go from 2x to 4x, but if you apply it once. Each time you apply it, it'll double again. So 1 plus cosine of 4x over 2 squared. So apply the formula inside. Now square this, that will give you 1 plus 2 cosine 4x plus cosine 4x squared over 4. You square the bottom, you get a 4. You square the top, you get these 3 terms. Just doing your distribution or FOIL or whatever you want to call it, you just multiply it twice. So notice how I have another square, right? So the 4th is kind of confusing, so I'm going to ignore it. And I'm going to pull it out in front as of 1/4. That way you don't have to deal with it. So all I have to deal with now is this it's cosine squared 4x. So apply it again. So the 4 will double to an 8. So you're going to get 1 plus cosine 8x over 2. Does that make sense? So then well, at this point we're done actually. We can just multiply the 4th inside and we're done. So this will become a 1/4 plus 2 cosine 4x over 4 plus 1 plus cosine 8x over 2. Oops, actually 8. Because 1/4 times each of these, this should be an 8. Now, if you want to combine the fractions, you would have to change these to an 8. You don't have to. But if you did, this would be 8 multiplied by 2 over 2, multiplied by 2 over 2, that'll be 4, right? Now I can put them all in one fraction. This part is not necessary. This is just algebra, right? If I factor an eighth in front, or put them all over 8, you will get 2 plus 4 cosine plus 1 plus cosine 8x. This is as pretty as it's gonna get. Let's see here. Actually, 1 plus 2 is 3. Forgot about that. Anyway, is there any question on this? Is that all right? Or are you guys dead tired today? Is that what it is?
Dead tired. And the 1 plus cosine something x over 8. What is that?
Where? This one?
Yeah, the 1/4. Yeah. No, up one.
Oh, here.
No, up.
Here?
Yeah, the 1/4, starting with the 1/4.
This line
The
says,
last term.
yeah, 1/4 plus 2 cosine 4x over 4. It's a weird 4. Plus 1 plus cosine 8x over 8.
Okay, that's an 8x. Thank you.
So the homework has it like this. So that's what they did here. So they had the 4th power and they applied it 2 times. And once they do all the dirty work, they get this pretty answer. So we did all the steps. Over here, they did the same thing. They have a 4th. They apply the tangent formula twice and do a bunch of algebra and get this. Okay. Let's see here. All right, so let's move on. So that's par reducing. There's 1 or 2 things left to mention. Here's a half angle problem. I think these are pretty straightforward, but we could do one of them. Let's do a half angle. Let's do 2 more questions and then we'll call it a night. Should be good. You guys cool on number 4?
Hold on, I was still writing it down.
Okay, yeah, there's no rush.
Okay, thank you.
Sure. Okay. Okay, use half angles. Formulas to determine the exact values. part A is asking for sine of pi over 8. So that's not on the circle. So what you can do is rewrite this as sine, because we know that half of pi fourths is an eighth, right? And pi fourths is on the circle. So apply let me look it up here. So we need this formula. Sine of, I think I used alpha, right? Or theta maybe, or that was x. So 1 minus cosine x over 2. So Rx, right, is pi over 4. So applying this formula, will give us square root of 1 minus cosine pi fourths over 2. Does that make sense? You just rewrite the question into an angle you know is on the circle.
Oh, what about the plus or minus, sir? Where'd that go?
So the plus or minus is decided by where the location of this angle is at. Remember, I think we said in the notes. Go back a couple pages. Sines of sine x over 2 and cosine x over 2 depend on which quadrant x over 2 is. So where is pi over 8? Which quadrant is that? But we know pi over 4 is quadrant 1, correct?
Yeah.
So half of it should still be in quadrant 1. It's like, this is 45 degrees. Half of 45 degrees is still in quadrant 1. So we choose the plus. That's why it's positive. If
Okay.
this was somewhere else, and then that may change the sign. Does that make sense?
Yeah, I'm just writing it down.
And we'll circle the plus because that's what we chose. Positive because pi over 8 is in quadrant 1. So now we just plug it in and we're done. So that'll be 1 minus cosine of pi fourths will be square root 2 over 2 over 2. And that's pretty much the answer. We could make it look a little prettier. That could be 2 minus 2 over 2 over 2, which will become this. So this is as pretty as it's going to get. But anyway, this was the answer technically. I added the fractions on top and then I divided by 2, which gave me this. Square root of 4 comes out as a 2. The top stays inside. That's all we did. So you have about one or two, about two of those types of questions, just find the sine, cosine, etc. Let me show you. See, the cosine is the same thing. It's just the formula has a plus inside of it. And then tangent was it's a different formula. You just plug in the numbers.
Oh, wait, sir, can you go back? I was writing that down for those.
Oh, sure.
Thank you. Okay, thank you.
Okay. All righty. These questions are basically applying the formula in general. They're very straightforward. We'll end the lecture with an easy one. Problem 17. Use product to sum. So we have a product, right? So what is the formula for sine? Sine 5, sine, I guess. So that will be equal to sine is 1/2 cosine of alpha. So this is my alpha and beta. So 5 theta minus 3 theta minus cosine of 5 theta plus 3 theta. So that'd be cosine of 2 theta minus cosine of 8 theta.
Sorry, sir. Is that a sine 5 theta and a sine 3 theta?
Yeah, sine 5 and 3. So this is my alpha and beta, 5 theta minus 3 theta, 5 theta plus 3 theta. So the section makes sense? Is it okay?
It seems okay. We'll see how the homework goes.
Okay. All right, just feel free to bring some questions next time, or I'll also send you I'll post the review for the next exam, and I'll post the next exam as well. I'm thinking, I don't know, there's no rush on this, so maybe the end of the first week of November, it'll be due. Okay. There should be plenty of time.
Sir, will you please go over the exam review with us? That was really like helpful and probably a key factor to me being successful on the test.
Yeah, of course.
Like I'm willing to like also just make time outside of class to go over it if I have to. Like,
No, we
Ser-
will. We will. We have plenty of time. Let's see here. Let me look at the schedule. Oops. So I think we're now. Yeah, we're just about on schedule, no longer ahead. So I guess on Tuesday we can have a review and answer questions about homework. So I'll save Tuesday for just reviewing. Okay.
thank you, sir. Seriously.
So yeah, just make sure you have try your best to look it over at least. That way, it'll going over it a second time is always great or good for you. Then on Thursday we'll do chapter 8 and go from there. You guys have any questions? Yeah, that's fine, Joseph. I mean, you can have the unit circle as a separate page. Don't worry about it.
What about the cheat sheet of the formulas that you sent us?
Yeah, those are fine too. I think it has all the ones you need anyway. If you don't want to make one, I mean, that's good enough. All right, guys, if you have any questions, you're welcome to head out, and we'll send you today's notes as soon as I can.
I'd like to ask you some questions for it, sir.
Sure.
Have a good night.
We're good.
So just off of stuff that we had. So I was like ask you about. This is less about the sine cosine stuff and more about just algebra that I've forgotten, I guess. The stuff that I starred that I really wanted to ask you about.
From today?
Yeah,
Or-
from today. From today.
Yeah, there was a lot of algebra that I skipped here and there.
It's just
Which one would you like to look at first?
the ones I really wanted to ask about were problems 6 and 15. So whatever one you want to go over first. I mean, you're basically right next to 15, so I guess we might as well do 15 first, and then we'll go to 6.
That's
If
okay.
that's okay with you.
It's all good. Let's go with 6. So are you talking about this step here?
Yeah. So
So
I'm
first thing we did
little,
is you
a
add
little-
1 to both sides.
yeah, on problem 6, I'm a little lost on like, what was the step? You know, like you don't ask a question, then you have to come back to it later, and you're kind of lost.
Yeah, so do you want to walk through this step here? Oh, you got solve for
Oh,
F?
not example 6. It was problem 6.
Yeah, this is problem 6, example 1.
Oh, okay. Yeah, I was lost on how we go from sine x to cosine x minus 1 equals 0 to suddenly like x equals 0 and pi to x equals pi over 3 and 5 pi over 3.
So you were cool up until the solution part?
Yeah.
Okay. All right, yeah, it's from the circle here. Let's open the circle up.
Okay. I have the circle in front of me, but I'm still kind of lost about where the 5 pi came from.
So look at the circle. What angles have an x value of 1/2?
X value of 1/2. 60 degrees, right?
Which
60
is,
degrees is 1, that's pi over 3.
yeah, right. And the other one?
1/2. 5 pi over 6.
Is it 6?
Yeah, it's 6. That's a 150 degrees. Oh wait, no, I'm looking at the wrong one. I'm sorry. I see a negative 1/2, but that doesn't seem right.
Yeah, it has to be a
Oh,
positive
wait.
one.
Oh, there's a 5 pi over 3. Okay, that's what was confusing me. I was looking at the wrong stuff. Okay, never mind.
So that makes sense, right?
Yeah.
Okay.
And then for sine x equals 0, you're just looking at the y values on the unit circle chart, right?
Yeah, find out which, yeah, look at the y values.
Okay.
That are 0.
So when y equals 0, so just at 0 and pi, huh?
Yeah.
Okay. I wish I wasn't so easily confused by this.
No, that's okay. It makes sense now. That's what matters.
Yeah. Oh, hey, you want to hear something cool?
Sure.
I got a 109 out of 100 on my chemistry exam.
Nice, man. That's awesome.
Yeah, 109 out of 100.
I don't know how that happened, but that's really cool.
I did a lot of extra credit stuff.
Nice.
Yeah, I was gonna tutor one of my classmates on Saturday to help her out with it, but no way in hell could I tutor for math.
Yeah, well, that'll help you master it further whenever you tutor someone in something.
Okay. Yeah, well that's the goal, but also like she just fell behind in class because she like her kid got sick and then the tutor she was using for chemistry ended up needing to take care of their mom because their mom got sick because everybody got COVID.
Oh man.
And
That
I'm like,
sucks.
oh yeah, so she's like 3 chapters behind in chemistry. So I'm gonna see if I can help her out on Saturday.
That's good. That's awesome
yeah.
you're doing that.
Yeah, I mean, she's gonna buy me coffee, so fair deal. But okay, let's do question 15, I guess. You kind of lose me like right around I guess the beginning. Fuck it, let's go with the beginning for that one, is where I started getting lost.